So in this video, we'll be looking at combining like terms. And one question that we can ask is, so what exactly does it mean to have like terms to begin with? Well, for that, let's define some terms. What we mean by an actual term. And what we mean by that is it consists of two parts. The first part is the number part, called the coefficient, and the second part is the variable part. And one thing to remember is that the coefficient and the variable part are all actually put together with the operation of multiplication. Now then, when we actually put terms together, we can put those terms together with the operation of addition. Now the thing about that is that we could have subtraction showing up, but we quite often don't think about using the subtraction. We really kind of refer to the subtraction as a subtraction abbreviation. And so for that, I'll point you to another video that I specifically have that kind of talks about subtraction abbreviation. We can say, what exactly does it mean to have like terms? Well, we say that terms are like terms when the variable parts match exactly. And so one example, if we've got a negative 3xy squared and a 5/7 xy squared, now these are like terms because I've got an xy squared on the first one, an xy squared on the second one. They match exactly, and so yes, those are going to be like terms. The negative 3xy squared and the 2x squared y, they are not going to be like terms. In my expression, what I have is that the xy squared consists of an x and two y's, whereas the x squared y is going to consist of two x's and one y. So because the variable parts are different in that case, these are not going to be like terms. So the property that we use to combine the like terms is the distributive property. Now, just to kind of remind you what the distributive property says, if we've got A times the quantity B plus C, then that's going to be the same thing as A times B plus A times C. Now, the important thing to remember here is that the A, we've got the same thing really multiplying B and C. This A is multiplying the B, the A is multiplying the C. That's the thing that makes it work. And so for us, the thing that's actually multiplying will be the variable part. And that's really the reason why that we need the variable part to match exactly. We need the same thing multiplying both numbers. And so let's look at an example, say 2x plus 3x. Now again, in this situation, what we've got is the x multiplying both the 2 and the 3. And so what that means from the distributive property is that we can really see this as 2x plus 3x as 2 plus 3 times the variable x. And so what can we do? Well, we can combine the 2 and the 3. 2 plus 3 is going to turn around and give us 5x. Now, in a similar example, suppose that we had something like 5x plus 3y and 4x plus 2y. Well, we've got like terms here in the 5x and the 4x and the 3y and the 2y. And so how we can really think about putting those together, we can really think about doing something like a traditional stacked representation where we've got our 5x plus our 3y plus our 4x plus our 2y. Now here in doing this, we've kind of put the like terms together. The x's are together above one another, the y's are together above one another, and so we can just think about adding those. 3y plus 2y gives us 5y. 5x plus 4x is going to give us 9x. Now really kind of what this is similar to is kind of the usual addition and subtraction that we may have been used to from arithmetic. And suppose we have something like 128 plus 231. Well, if we add those together, 8 and 1 gives us 9, 2 plus 3 gives us 5, 1 plus 2 gives us 3. Now, in doing that, our traditional kind of algorithm is that we add the ones places, we add the numbers in the tens places, and we add the numbers in the hundreds places. Now, where this is similar to kind of what we were doing before comes with our like terms really being similar to like place values. An x value, so maybe just a number, is kind of corresponding to this ones place, x values corresponding to one column, y values corresponding to another column, and so on and so on and so on. Kind of the only difference that we've got in that comparison is that in algebra, we really don't have to worry about carrying or borrowing. We're just combining our like terms together, so just kind of putting the right columns together, the right place values together. And so kind of the general idea is when we have expressions that have a lot of parentheses in them is to remove all the parentheses first, and then we're going to start combining our like terms. So let's look at an example, say 2 times the quantity 3x plus 1 plus 5x. Well, we've got the set of parentheses around the 3x plus 1, so we can use the distributive property to get rid of those. Now, what's going to happen in that case, we get the 2 times the 3x and the 2 times the 1. Now, the 2 doesn't multiply the 5x because the 2 is only going to multiply the things that are in the parentheses. And so the 5x is not inside, so the 5x doesn't get multiplied. So we've got a 2 times the 3x plus our 2 times 1 plus our 5x on the end. So 2 times 3x is going to give us the 6x plus 2 plus our 5x. Now if we go through and kind of look for like terms, we've got a 6x and we've got the 5x there as like terms. So if we think if I've got 6 of something plus 5 of something, then that's really going to give me 6 plus 5 is going to give us 11 of the something, so 11x plus the 2. Now the 11x and the 2 we can't put together because the 11x has an x on it. The 2 does not have an x on it, and so we can't combine like terms there. We don't have the same thing multiplying the 11 as we have multiplying the 2. And so kind of one final example, suppose we have a negative 5 minus a 4 minus 12p. Well, again, we're seeing this actually as a minus 5 minus 4 minus the 4 minus 12p as really being adding on a negative 1 times this quantity 4 plus a negative 12 times p. And so what we're distributing in this case is the negative 1. And so what happens there, we've got our negative 5 plus the negative 1 times 4 plus the negative 1 times the negative 12p. Well, the negative 1 times the negative 4 is just going to give us the negative 4, and the negative 1 times negative 12 is going to give us a 12p. So here we've got adding on a negative. We could think of using our subtraction abbreviation in that case. And so we have negative 5 minus 4 plus our 12p. The negative 5 and the 4, those match because they're just numbers, so they're like terms. Neither one has a variable part. And so because they're just numbers, we can put those together. So minus 5 minus 4 is going to give us a minus 9 plus our 12p. Again, we can't combine the minus 9 and the 12 because the negative 9 doesn't have a p on it. We don't have the same thing multiplying each one of those terms. So this has just been a little bit about combining like terms. Hopefully watching this and some of the other videos that kind of go along with it, get some practice in with some real problems, and you can kind of begin to see what's really going on there. So stay tuned for more.